So our next topic is compute on the cloud, or compute in the cloud. And there are multiple resources or multiple services provided by AWS for compute. And in this Cloud Practitioner, the only compute services that we're going to be talking about, actually two of them, we're going to be talking about Amazon EC2. Then we're going to be looking at introduction to what is called container service. So AWS provide, under solution architect, we're going to be looking on EC2. We're still going to be looking at about EC2, container service, lambdas, and other compute services. But here, for this particular topic now, we're going to be looking at EC2 in the cloud. So objective of this module is, one, we're going to learn the advantages of EC2. You are going to recognize the different types of EC2 instance. You're going to understand the options, the billing options that is available for you. When you are using an EC2 instance, how do you pay, or what are the billing options? Some billing options are much cheaper than the other. So you need to understand all of these billing options. Then, not today, we are going to be looking at auto scaling, but the only one that we're going to be looking at today is EC2. So later, tomorrow, we're going to be looking at auto scaling, load balancer, and some services called managed service, which is a SNS and SQL. So now, let's look at Amazon Elastic Cloud Compute. Amazon Elastic Cloud Compute, it's actually a service provided by Amazon for you to be able to run compute services on the cloud. If you are managing your own data centers, in your data centers, you will have some compute resources. And one of the major compute resources or compute services that you have on your own on-prem data center is server, which we have looked at several times. So if you want to use cloud now, and you still want to use that server, so what you are going to be using as as server on the cloud is what we refer to as EC2 instance. So with EC2 instance, Amazon EC2 instance is a service provided by Amazon. This is a service. Amazon has a lot of services. So this is one of the services provided by Amazon. And to be candid with you, this is one of the most important service. It's called one of the core services in AWS. Like I said earlier, that hardly you will see a company that is using Amazon Cloud Platform that they are not using EC2 or a fraction of EC2. So this is one of the core services. We are going to see some other core services later, but this is your number one core services in the cloud. Then the main features of this service, or the service that this service provide, is the server. So when you are using server on-prem and you want to migrate to the cloud now, and you still want to use server on-prem, then this service will provide you that server on the cloud. So that name, the name for the server on the cloud, because it's not something you can now touch. Like the one you have on your on-prem, you call it physical server. But now that is the on-prem, it is now referred to as virtual server, because you can't see it, but you can actually log into AWS account. You can view how the server is running. So this is referred to as virtual server. But like every other cloud that has virtual server, they gave it different name. So AWS give their own virtual server, Amazon EC2 instance. So when you hear some people say, I'm spinning up an instance, this is what they mean. They are spinning up a server on the cloud. Some people might call it spin up a server. Some might say launch a server. So it still referred to the same thing, is instance. Someone just refer to it as instance. So instance is one of the core services that you can get under EC2. Also, when you are using EC2, it provides on-demand, EC2 provides you on-demand scalable compute capacity or resources in the cloud. So the EC2 instance is not the only service that EC2 provides. It has other services that we are going to be looking at. I said earlier when I was showing you the topic we are going to cover, I talked about auto scaling, I talked about load balancer. All those services are provided by EC2, and they are meant for you to be able to scale your compute services or compute capacity in the cloud. So EC2 is, as I said earlier, is one of the main topic that you need to pay a lot of attention on. You need to spend a lot of time ensuring that you understand it very clearly. Now, let's look at the features of EC2. Features of EC2. Like I said earlier, one of the main service that EC2 provides is instance. Instance, which is also referred to as virtual service. And don't get it wrong when somebody refers to it as VM, which is called virtual machine. And in IT, I mean in corporate world, you will hear different names, but all of them still mean the same thing. They are talking about server, virtual server. You might hear virtual server, you might hear VM, you might hear EC2 instance, you might just hear instance, and some might just call it machine. So everything is the same. So that is the first features that you're going to get on EC2. Then the next one is the Amazon machine image. Amazon machine image. So when we are talking about server, remember when we are talking about physical server on-prem, we talk about the hardwares on that server. And all these hardware, you can't use them, right? Because the only language they understand, they are zeros and ones. So we need somebody, an intermediary, to pass human readable data to the machine, to convert human readable data to machine data. So that is where we have the what? Operating systems. So the operating system now, when you have physical server on-prem, you can specifically deploy any operating system that you want on your server. So the same process or the same concept, you can use any operating system that you want on the cloud. But on the cloud now, we don't refer to it as operating system. I mean, we don't refer to it as operating system. We refer to it as image. We refer to it as image. So AWS provides you Amazon machine image. And this machine image is not ordinary operating system. It's the baseline, or it's a basic operating system plus some other applications, pre-configured applications. So this is the pre-configured operating system plus other software that you need for your or on your servers. So it is an operating system, but other things have been added to it. So it has been pre-configured. So when you are spinning up your server, you just select a specific operating system called AMI. So any AMI that you select, it comes with the operating system plus some other software. So this makes it possible for you to be able to quickly spin up a server and you have all the resources that you need, or all the applications that you need, or all the dependency that you need for that server. They are already on the server. Then we have the instance type. One thing that drives your choice of laptop, or your choice of server, or your choice of car is the capacity, the components of that laptop. If I ask you now, why do you pick the laptop that you are using now? When you went to buy it, why do you pick this specific laptop? You will hear some people will say, oh, because it has a lot of RAM. Some people will say because it have a lot of storage. Some people will say because it is so fast, it have a good network capacity. All these, you still need the ability to select all those things in the cloud. So AWS has already categorized some of this in form of instance type. So they have a lot of instance type which have various configuration of compute, various configuration of memory, various configuration of storage, network capacity, and graphic hardware. So all of this determines the instance type that you pick. So there are a lot of instance types. So any instance type you pick is derived or is based on the capacity or the configuration of the hard components that you need, like the CPU, the memory, the storage, the networking capacity. So the instance type has this. And if you are configuring any system, you have to specifically pick an instance type. So the next one is the instance volume. Your instance volume is the storage on the cloud. Remember, when you have your physical data set, your physical server, you need either an hard drive or a solid state drive on that server. So if you want to select an hard drive or a solid state drive on the compute on the cloud, this is where instance volumes come in. So for the instance volume, for AWS, we have two specific instance volume. We have the elastic block store and we have the instance store volume. If you have a data that you need to store on your laptop, on your instance, on your computer now, or on your server, if you have a data that need to persist, that means a data that you need anytime you turn off the data, you turn off the server and you turn it all back, you still want the data to be there. Then that is when you use the elastic block storage, because it keeps your data even if you turn off the data, if you turn off the laptop, if the laptop is bad, or if the server is bad and you need to change the server, then you can come back and still get your data. But if you use the instance store volume, it doesn't make your data persist, meaning that there are some circumstances that if they occur, every data stored in the instance store volume will be wiped off. Example of that circumstances is if you turn off your instance, if you store a data in instance volume and you turn off that instance, that data will be wiped off. If the instance is corrupt or it got spoiled, that data will be wiped off. So when we get to solution architect, we're going to be discussing more on instance store and the factors that can cause your instance store data to be wiped off. Then the other features of Amazon EC2 is that it gives you a private IP address to your server. A private IP address. This doesn't mean that you cannot append or attach a public IP address to your server, but by default, when you spin up a server or you spin up an instance, it automatically comes with an IP address. The next one is key pair. This server that you're going to spin up on the cloud, you need to be able to access them. And you're going to be accessing them over the internet. So we need some level of security, such as the username and password, because every computer, even your own too, has username and password if you configure it. So if somebody that is not a member, or that is not you, or a member or a trusted person to you, want to use your laptop, then you will first need to request for your username and password for your laptop before you can log in. So also on the cloud, we can use username and password for our server that is in the cloud. But username and password are not secure. It only takes a matter of time before it is decrypted, or if it is compromised. So people tend to use what is called a key pair, which is like a encrypted key instead of username and password. So for you to be able to access your server on the cloud, you need a key pair. The key pair is a secure login information for your server. When we get along the class, I'm going to be telling you the different kind of key, the two types of key that you have, which is the private key and the public key. So now let's dive deep into the types of Amazon instance type. So AWS has a lot of instance type that we cannot start mentioning all of them one by one. But what they do for us is that they categorize them. And for for Cloud Practitioner, you don't really need to know all those instances, the instance that comprises an instance type. All you just need to know is that the category's name. Even for solution architect, you still don't need to be able to select a specific instance time. You just need the category and why you should choose an instance from a particular category. But when you're talking about solution architect professional, then you need to be able to select a specific instance in an instance category. So now the first instance type category is what we call the general purpose category, or general purpose instance type. So under this general purpose instance type, this is where we have instances that are used that has balance between compute, memory, and network capacity. So what does this mean? If you want to spin up a server and you are not really concerned about the storage, you don't concern about the memory, or you are not really concerned about network capacity, you just need something that is functioning enough to handle your work. So you don't really know whether, you are going to be doing a lot of compute, or you are going to be doing a lot of memory, or the server will be used for networking. You don't really know. So this is the best category for you, general purpose. Then the second one, for the general purpose, it is suitable for a range of workloads. A range of workload, meaning that for a lot of things, even if you want to test a server, like before you actually deploy the Azure resources, you want to test whether if I deploy these resources, it's going to work fine, then you can deploy it on an instance that is categorized as general purpose. Then the second one is what we call the compute optimized. For the compute optimized, this is when you need a high performance processor. Remember, when our first class, not the first class, the second class, when we start talking about components of computer, we did talk about CPU, which is like the brain box of the computer, which is like the brain of the computer. So if you need a server on the cloud that has a lot, or that will be using a lot of CPU capacity, processor capacity, then you need to select an instance type from this category called compute optimize. So compute optimize is ideal for compute intensive application or batch processing. And if you need an application that need to run that will be using a lot of CPU, and don't forget that CPU is what we call central processing unit, CPU on-prem. In your physical server, you call it CPU. But on AWS Cloud, AWS refers to it as virtual CPU. So you can still see that all the concepts that you already know on-prem is what we are bringing to the cloud. And it's not only on AWS Cloud, it's the cloud general. That is why when people say, when you know one cloud platform, you know other cloud platform, because they are all the same. It's just the name that are different. The next one we are going to look at is called the memory optimized. The memory optimized is when you need a lot of memory. It drives fast performance, delivers fast performance for memory intensive workload. Like for instance, you are running a database that people can go on your site. Okay, now let's look, for instance, now you go on Facebook, you are chatting with somebody on Facebook. Both of the person is talking and you two, you are talking, both of you are communicating on Facebook. Those kind of data cannot be stored in server because it will take some time. If you have stored those kind of data in the storage, it will take some time for that message to get delivered to the user. So that kind of message are actually stored in the memory, so that any data stored in memory are easily accessed by the operating system. We just don't go deep when we are talking about computer. We don't go deep into how computer cache memory. There are a lot. Guys, give me 1 second. Somebody's at my door.
Are you still talking?
No, he stepped out.
All right, guys. All right, I'm back. So when you are running memory optimized, those are, memory optimized instance, if you are working, or if you have a workload that needs a lot of memories, then you are going to be picking an instance from memory optimized category. And for, as I was explaining earlier, like the application, like Facebook, that when you are chatting with somebody, that message, immediately you press enter, the person sees it. When you type, the person sees it back. Those kind of messages are actually stored, but at first they will be stored in the memory so that it can be easily accessed. But if that kind of data are first go and store in the storage, and because for the system to have access to it, it's going to take some time, because when data has a multiple places they were stored on your computer, you can some data are actually stored on the CPU itself, while some data are stored on the RAM, which is the memory, then while some data are stored in the hard drive. If you need a data, if you have a workload that need fast access to data, then you're going to be picking from memory optimized. The next one is the accelerated compute. When we are talking about the accelerated compute, this is when it actually uses like a hardware. It's like external component that is attached to a compute optimized system. It has a more higher level to compute optimized system, but it's actually meant to be extremely processing or expedite a data process. That if you want to make something extremely quick, running a lot of process is different from running it fast. So this is actually used to, if you have a workload that needs a lot of compute capacity, then you're going to be using compute optimized. But now, if you need that compute capacity to be extremely fast, then this is when the accelerated compute comes in. So if you want to expedite a data processing, then this is where you're going to be picking from. And the next one is what we call the storage optimized. This is where you need a lot of storage. It doesn't mean that those storage need to be easily accessed, but it just need to keep a lot of storage. So if you need an instance that can keep a lot of storage, maybe you need, maybe for this kind of instance that I use for log, when somebody is accessing, like how you access your server, if you access your laptop, everything you are doing on laptop, everything you are doing, they are being recorded somewhere on your system. It's called log. So if you leave your laptop on your table and somebody go there and start checking on your file and do some things on your file, you can actually see that person when you go to the log. You can see what activities somebody performed on your system. So that system, if it is a system that store a lot of logs, then it needs a lot of storage. So if you have a workload that need a lot of storage, you are going to be selecting from storage optimized. So when we talked about low latencies, I've been talking about low latencies in this class, and I believe that somebody should have checked it up now what it means. And I did explain about it the other time, that the time it takes you to request for a service and the time it takes you to get the service back, that is latencies. Then there is another one that you normally see in the cloud. They call it input output per seconds, IOPS. Input output per seconds, IOPS. What this simply means is that when you make a request, how many requests can you make within a second? And how many response can you get back within a second? That is input output per seconds. Then the third one is what is called the throughput. That is not here. It's called throughput. So throughput is how many bytes of data can you send at once, and how many can you get at once within a second. So if you are communicating with somebody, maybe you are chatting with somebody and the person is typing so slow and you are typing fast, then the amount of communication that both of you can make will be reduced. But if both of you are typing fast, then you can make a lot of communication within that short period of time. So that is like a concept of input output. How fast is the input and how fast is the output? Then when talking about throughput, you can see that in terms of, okay, when somebody is typing, somebody that is extremely slow in typing, that he doesn't know the keyboard, he has to do finger picking when they are typing. Maybe those people that type with one hand, one finger. So that kind of person, if they are to write a message, then it's going to take them a lot of time, and the message they can write will be very few. So, or another concept that you can use is that if you have two buckets, and inside one bucket the bucket is full of water, and the second one is empty, and somebody is asking you that, okay, you need to take the water from the full bucket, you need to move them into the empty bucket, and they give you a bowl. So the question now is that the bowl that you are using, how many what is the quantity that the bowl can take at once and put in the second bucket. That is throughput. If you have a jug, a very small mug, if you have a mug can take a very small data from one bucket into the second bucket. But if you have a paint bucket, it can take almost every water in that bucket with like 2 or 3 times. So that is the concept of throughput. Like the throughput is measured in bytes. Like how many bytes can you take within 1 second? While the input output is mentioning how the speed, how far can you go within seconds? How far can you go and come back within seconds? While throughput is how many quantity that you can take at once. So those are the two different. This always come out a lot, and you will hear people ask you this in an interview. What do you understand by input, throughput? What do you understand by output and low or latencies? You always want to have low latencies. High latencies is bad. It makes your application to be extremely slow. But when the low latencies, it means that it's request and you get it immediately.
Can you spell that throughput, please?
THROUGHT, throughput. THROUGHT, like true.
Oh, throughput. Okay.
Yeah.
Thank you.
All right. So these are the instance capacity that we have, instance type category that we have on the cloud. So the next one that we want to look at is the pricing, EC2 pricing model. When you spin up an EC2 on AWS, when you spin up an instance, a server on AWS, you pay for that on demand. That's used on demand. When you go to AWS and spin up a server, it's used on demand. That means you only pay. You pay as you go. You pay for what you use. If you use it for 5 minutes, you only pay for that 5 minutes. If you use it for 1 day, you pay for 1 day. If you use it for 1 year, one year, you pay for 1 year. That is pay as you go. No story around it. If you spin it up now and after 2 seconds you off it, those are what you are going to pay. But it's charged, the minimum that you can use is 1 minute. It's charged like 60 seconds, which is 1 minute. That is the minimum. So if you turn up a server now and the server is just like 5 seconds and you turn it off, so you're still going to pay for 60 seconds. But immediately you pass that 60 seconds, then you keep paying as you go. So one thing about this on demand is that there is no contract. You don't have to first call AWS like, hey, I want to use this instance. What are the contracts? You don't have to do that. And no upfront. You don't pay before you use it. When you use it, when you finish using it, then AWS calculate how much you have, the amount of time, how long you have used it, and they bill you based on that. That is on demand. And this is very good for application that you just want to run for a very short period of time, maybe for like 1 week, 1 month, 2 months. Those are the kind of application you can use on demand for. And any workload that you don't know what it's going to take, maybe you are not really sure what kind of instance this application needs. Maybe this is your first time of testing it on the cloud. Then these are the pricing model that you can go for. But if you are sure of the time that you are going to use this application and you are so sure that you're going to use it for more than 1 year, then this kind of pricing is not good for you because it's so expensive. So there are other services that AWS provide that once you are sure that you are going to use this for more than 1 year, then the first service the first pricing model that AWS introduced is called the reserved instance pricing. So with this, you have to tell AWS, you have to reserve that instance. Hey, I'm going to use this instance for 1 year or for 3 years. So you can either do 1 year or 3 years. And guess what? If you reserve that instance for 1 year or 3 years, what it means is that you have committed that you are going to use that instance for either 1 year or for 3 years. So if you commit that you are going to use it for 1 year, that means AWS are going to bill you for 1 year. But guess what? They are not going to bill you the actual price. They are going to give you discounts of up to 72%. So if you are using on demand for $1, if on demand costs $1 to use for that 1 year, I'm just saying, if on demand costs $1 to use for that 1 year, then if you have reserved it for that 1 year, you would have paid just 28 cents, which is 72% discount. So this kind of data is, this kind of pricing model is used for when you know that, okay, this workload is going to be for 1 year, and any mission critical application that you cannot turn off, that you can't turn off the server, that the server has to be available, has to be running for good 1 year, then these are kind of pricing that you want to go for. Then the next one is called the savings plan. Unlike the reserved instances, you have to specify an instance that you are reserving. You have to specify the instance family. Whether you want to use a compute optimized, you have to specify that I'm using this kind of compute optimized, or I'm using this kind of storage optimized. But if you are using savings plan, this is actually in terms of price. So it's still going to be between 1 year and 3 years, but you have to commit in terms of price. Like, I'm going to use a service worth of 100,000 within this year. So if you commit based in price, then they are going to give you discount of up to 66%. So under this, we have two types of savings plan. We have the compute savings plan and we have the EC2 savings plan. The compute savings plan, it gives you the flexibility to choose any compute service. So if you reserve a compute savings plan, you can use any EC2 and still get that discount. You can use container and still get that discount. You can use Lambda, you can still get that discount. So any compute resources, any service that AWS specify as this is a compute services, you can use them if you reserve compute savings plan and still get that pricing and still get that discount. But AWS specify like 4 service. We have the EC2, we have the Lambda, we have the SageMaker, and we have the container. If you go to pricing, AWS pricing calculator. If you go to AWS pricing calculator, which is a site, so if you go to this site, I use this every day. So if you go to this site, you have to pick the service that you want to use. Let me just say, create an estimate. Let's say, for instance, you have to select the region that you want to use. Then let's say I want to find an EC2. So this is an EC2 service. If I say configure, so here now, you can specify a particular service. I can say I need just one instance. And look at that. When you specify that instance and specify the instance category, but if you scroll down, you can see these are different payment methods. You can choose a compute savings plan. And if you choose a compute savings plan for 1 year, and you can pay no upfront, you can pay partial upfront, or you can pay all upfront. So if you pick any of these, then AWS will give you a discount. So for instance, now let's just look at one AWS instance. Let me just look at T2.micro. I mean T2 medium. This is an EC2 instance type, the instance type that we looked at earlier. So look at how much this is going to cost me if I use on demand. On demand is going to cost me 0.464 if I use on demand per hour. But that same instance, if you try to use it per savings plan, by compute savings plan, what is going to cost you per month? This is what is going to cost you per month. If you look at, let me pick on demand. So if you go to the on demand, the amount that this is going to cost you, if you go to the calculator here, show summary. Go back one step. If you go to the calculator, if you calculate that price per month, 1 hour, if you calculate it per month, it's going to be more expensive than if you choose either of the savings plan. So that is why, if you are so sure that you are going to use, okay, this is demand here. Now look at the price. If I'm using savings plan, compute savings plan, I'm going to pay $1.53 per month. But if I'm using on demand, look at it, $3. That is a very cheap instance that I pick. Let me pick another instance that is kind of expensive. Let me go for i3en.24x large. Don't bother about all these instance category first, but what I just want you to pay attention on now is just the pricing. Look at the pricing for this instance for 1 month. This is, if I use on demand, I'm going to pay this on demand, 7,000 plus, almost 8,000. But if I use compute, I'm going to pay just 3,000. If I use EC2 savings plan, I'm going to pay 3,000. If I use reserve instance, look at this, I'm going to pay 4,000. You can see how cheap both reserve instance, compute savings plan is compared to on demand. So companies tend to, if they are sure that they are going to use this service for a specific period of time, for like more than 1 year, they always go for either reserve or compute savings plan. So the next one that we're going to look at is the spot pricing. The spot pricing is another payment option that this one you don't have to pick like a year. You just have to pick, because AWS have a lot of service, a lot of instances that they are not using and no customer are using it as at that time. So instead of them not to make any money on that kind of instance, they make it available for you to use. But what you have to tell them, this is how much you will pay. So this is like you bargaining. You have to tell them how much you are going to pay. So, but this is the problem here. Let's say the instance, the on demand is $1. And because nobody is using it and AWS need money, they now say, okay, bid for it. How much do you want to get it for? And you say you want to pay 2 cents. So what costs $1? Normally, you say you want to pay 2 cents. AWS is not going to argue with you. They say, bring that 2 cents. At least it's better for nobody using it. At least we are making 2 cents. But immediately somebody show up that, hey, I need this instance that you are currently using 2 cents. If somebody show up that I need this instance, AWS will give you just 2 minutes to terminate, to remove your resources on that instance. Else they will terminate it and give it to the person that actually needs it, that can pay higher than you. So the spot instances they offer a lot higher higher discount. This time around, they offer 90% discount. This is the highest among all. But you only use this for resources or workload that you know that can be that is dynamic or that is not critical mission. If you have a workload that you cannot turn off the server, then you can't use spotting instance, because if you bid for a particular server and you are using spotting instance and somebody comes and they say, hey, I need this instance, then AWS, if you don't terminate it or remove your resources from it, AWS will terminate it and your resources is gone. So you use this for any resources or workload that you know that it is fault tolerance. That means it doesn't care. If somebody wants to use it, you can pause what you are doing, let the person finish, then you go back later and do your stuff. So if it is that kind of workload that you are running, then you can use spot instance. Also, you can use it for stateless workload. A stateless workload is still the same thing I explained earlier, that if you are performing a task and somebody calls your attention to do something else, and you can still come back to that task, and you don't care, you can start from anywhere that you stopped before. Or if where you stopped has moved, you can start from wherever place that you found yourself. Those are stateless workload that does not have a specific state. You can start anywhere. So the next one that I want to introduce to us is called dedicated instance. So this is an instance that, this is an AWS instance that if you have to pick and you pay for it. So let me use a very simple words to explain that. If you spin up an AWS EC2 instance, it's actually spin up on another server, but that server, a physical server, if you spin up an instance, it's actually spin up on a physical server. But what you will be seeing is a virtual server. But that server that it's spin up on, you are not the only one that has an EC2 instance on that server. And that is the concept of shared tenancy. That means you are sharing the operating system, you are sharing the hardware with other people. But in a situation whereby you need a dedicated instance, that you don't want any other tenants to share it with you, but it's still going to be an EC2 instance, but on the physical server that is running that EC2 instance, you want to be the only one that is using it. So this is dedicated instance, and you have to pay extra amounts for it because it is higher, it is more expensive than just spinning up ordinary instance. Then the second one is called dedicated host. A dedicated host is when you actually tell AWS that, hey, I want to spin up a server on a physical server in your on-prem. So this time now, AWS is going to give you a physical server on their data center that is going to only belong to you and you alone, no other person. So, but this is the most expensive because you are using actually a physical server, and you can specify the kind of server that you want. So these are the pricing model that AWS have.
Please watch it back. Please.
What do you say?
Can you go back one step, please?
Oh, okay.
Thank you. Got it.
All right. So now,
Can I ask a quick question before we go far?
all right.
Please. I was wondering, so what is the main difference between the reserved instance and the savings plan? Since based on pricing, the savings plan can tend to be cheaper. The reserved instance tend to get more discount than the savings plan. So what is the essence of having a reserve plan versus the savings plan?
Okay, that's a very good question. So when let me go back one step. If you go to the savings plan and reserve instance, the savings plan, even AWS itself, they will tell you that instead of reserve instance, you should do EC2 savings plan because they are actually the same thing. But now, with EC2 savings plan, you can actually change family, the instance family. When we get to AWS Solution Architect, I'm going to be showing you instance family. Like if you look at the instance that I just, the instance type that I pick here. So this has a specific names. The first letter here before the dot, that is what they refer to as the instance family. So with EC2 savings plan, you can change an instance family. With compute, you can change a whole service. But with reserve instance, you have to select a specific instance family and you have to select a specific region. A specific availability zone. That if you pick availability zone 1A, that is where you can only spin up that service. But AWS now give you an option now that you can use what is called a convertible reserve instance, because there are two kinds of reserve instance. There is standard and there is convertible. We are not going towards that route, but we're going to get there in Solution Architect. But your purpose here is just to understand that there are different options, pricing options. You can use on-demand, you can use reserve instances, you can use savings plan, you can use sports, savings, sports pricing, and you can use dedicated instance or dedicated host. Guys, give me 1 minute. I'm coming. I want to quickly ask somebody something. Sorry guys, I'm back. So now let's quickly look at how to get started with EC2 instance. Now we are going to the console. I might have to stop this class exactly 12:05. Somebody wants to use my office to write AWS exam. So sorry guys. So here, the first thing before we go to the console, if you want to deploy any resources in the cloud, the first thing for you to do is to architect the resources that you want to deploy in the cloud. That is why when you go to different websites, I hope you guys can see my screen. If you go to different websites, we go to AWS architecture diagram, just image. You will see a lot of architectural diagram. These are the solutions that some people have provided. All these diagrams that you are seeing here, they are not just ordinary diagrams. This is what they call architectural diagram. And somebody that designed this, they must have deployed, or they may want to deploy all these resources in their cloud. And those resources, this is how they will be communicating with each other. So we're still going to get here under Solution Architect, but for now, I'm going to be showing you a very basic architectural diagram. So how do we draw architectural diagram? When we get to Solution Architect, we're going to do that, but let me just show you this. If you want to deploy any resources in the cloud, first thing, we need to draw your architectural diagram. So on the architectural diagram, we need AWS cloud. So this just shows that, okay, this is being deployed on the cloud. Then after that, you need to select a specific region that you want, where you want to deploy that resources. Once you select this specific region, you have to determine which availability zone inside this region do we want to use. Then once you select that availability zone, then this is when, after that, you now be talking about the instance that you want to deploy. So this instance will be deployed inside this availability zone. Then after that, we're going to be talking about the security of this instance. So AWS provides us a service called security group. This is like a firewall on the cloud. So this is a very basic architectural diagram. And guess what? Guess what? Users or administrator will need to administer this server. So for them to be able to administer this server, they need to have access to that server from the internet. And once they need access to this server from the internet, they need what is called keys. That is what we call the key pair. So there are two key pairs. We have the public key and we have the private key. The public key is always on the server itself. It's going to be stored on the server, while the private key will be with the administrator. So now, if you spin up a server on the cloud, you will be the administrator. So you need a private key. So before you spin up the server, you must first configure all of these. Then after that, we have our server. So now it is now that you have this that you can now go to the console or through the CLI and deploy this. This is a very basic architectural diagram, but guess what? This is required before you start deploying resources to the cloud. So for those of you that want to become a solution architect, this is your #1 responsibility. This is what mostly solution architects do. But it doesn't mean that you shouldn't be able to deploy these basic resources to the cloud. You should, but this is your responsibility here. You are the one responsible to draw this architectural diagram. So now for the demo class, I'm going to push that to tomorrow because it's 12 o'clock already. So for tomorrow now, we are going to start going to the console and start deploying this architectural diagram in our console. So any question from here?
Can we use the virtual thing for this too?
Virtual team? What's virtual team?
Hold on, sorry. The one you send the video less?
No. That is Visual Studio Code.
Yeah, Visual Studio Code. Can you use this on there?
No. So for you to draw this architectural diagram, you will need to register on this. There are a lot of them that you can use, but there is one that I love, and that is where I do that. It's called Lucy Chart.
Can you send the video up to please?
Lucy Chart. Hold on, yeah. So just go to this website, register there. So you have access to this Lucy Chart. So you can see I have a lot of architectural diagram already on there. And this is the one I use for last batch. I have all the architectural diagram for last batch here. So you don't need this now. When we get to solution architects, anybody in the solution architect must register for this. You can do the paid.
Can you send the video when you have time, please?
The video?
Thank you. Yeah, thank you, sir.
I don't have video where I explain this, but there are a lot of video on the YouTube, but I can send you the link, Lucy Chart.
Thank you, sir.
I think implicitchat.app. Yeah, that is the link. So if you go to that site, just register for it. You'll be able to use their tools to draw a lot of architectural diagram. So all those diagrams that you see, this is how they draw them. It's not something technical. So that's why. And the funniest thing is AWS solution architects pay more than security for the same level, but me, I like security better. Because as a solution architect, you need a very good understanding of the resources, like all the pricing options. You have to know them. You have to know all the instance type. You have to know all the storage components and things like that. But you don't deploy, you just know them so that you can tell somebody, hey, if you need this, go and use this. If you need this, go and use this. If this is your problem, this is what you need to do. But some company, they will bring you in as solution architect, and before you know it, you are their civil engineer. So, all right. With no more questions, I want to say thank you guys for coming today. Let's see tomorrow, 3 p.m. to 6 p.m. Central. Any other questions?
I wanted to know if this is a paid service, the Lucid Chat. Is it free?
No. It's free. Some versions are free. Like me, I'm using the paid version, but you can have access to the free version as well. I was using the free version.
Does it have all the? Does the free one have the required features that we need?
Yeah.
Okay.
Yeah.
Hello. Hello, sir. When you were talking about logs, when you were talking about logs in
I don't
AWS.
know who is talking. Can you give me your name?
Yeah, my name is Islamia.
Oh, okay. Right.
When you were talking about logs, about recording logs on your laptop and all, are you does it apply to Splunk?
We are going to be looking at Splunk. So on your own system, there is log. Every system has log file. So where Splunk comes in is that the log that you have on your system, if people that you need people to monitor it, so every people that are monitoring it, they can't come to your system and be checking. So all those logs need to go to a centralized place where people can monitor them, and that is where Splunk comes in.
Okay. So another question is, example, I have already have AWS account that I'm already using for some other things. Do I need to create another account using another email? I can still use.
Yeah, you can
that
still
already started using with EC2 user and all that. So
yeah,
I
you can
still
use that.
continue.
You don't have to create another one.
Okay, thank you.
All right. Thank you, guys. Let's see tomorrow, 3 to 6 p.m. Central.
Thank you, sir.
All right. Bye.
Thank you.
Thank you, sir. Thank you.